So this is a video that goes with page 13 of your proportions packet. And we're going to start up here now with question 10. The liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to 500 kilometers. What that means is that 1 inch of the scale model represents 500 kilometers of the actual outer core of Earth in real life. How thick is the liquid outer core then of the model? All right, so we're basically converting here, y'all, and we're converting inches to kilometers. We've been given that 1 inch represents 500 kilometers, and we're going to use that now to convert. We want to find the number of inches in the model if we know that the actual distance of the outer core is 2,300 kilometers thick. At this point, we can cross multiply and divide. Some of you are going to take the 2,300 and divide it in your calculator by 500 to get the scale factor. And if you do that, that's totally fine. That just means you just have to multiply by 1 here, which is already going to be the answer. So for those folks who want to divide 2,300 by 500, you're going to get the 4.6. That lets you know that the scale factor is 4.6, and so when you multiply there, we get D. Now if you cross multiply and divide, we get 500x equals 2,300. And because of the way this problem is set up, you're actually going to be doing the same thing in the calculator, the 2,300 divided by 500, and we get a 4.6. So what that means is that in our little model of the Earth, 4.6 inches thick on the model represents the total core, the outer core of 2,300 kilometers. All right, moving along. So for number 11, we're given that the ratio of boys to girls in a math class is 4 to 5. First, I want you to ask yourself, does that mean that there are more boys or girls in the class? Well, if there are 4 boys for every 5 girls, that must mean that there's going to be more girls in the class. All right? So the ratio of boys to girls was given to us, and it's 4 to 5. Now we also know that there are 20 girls in the class. So we want to know how many boys there are. I think this one's going to be very easy to spot. The scale factor is 4. So if the scale factor is 4, we're going to have 16 boys in the class. Obviously, we can see that 16 is less than the 20 girls. There are more girls in the class. Okay, so we have a traveling problem, and Luigi is heading to Mexico. He exchanged 750 US dollars and got 2,000 Mexican pesos back. Now, if the exchange rate is 1 US dollar for every 3 pesos, I want to know if he actually got the correct amount. A lot of us, when we go traveling in the airport, we might take our cash with us, and we're like, all right, here's my American money, and I want however much currency back in whatever country I'm traveling in. And it's up to us to make sure we're actually getting the proper amount of currency for the country that we're traveling to. So in this problem, we're comparing the US dollars, the US dollar, to the number of pesos. And we know that 1 US dollar is worth 3 pesos. So if he's going to exchange $750, let's figure out how much money he should get. And right here, I think a lot of you can see a scale factor of 750. So all we got to do is take the 750 and multiply it by the 3 down here to get that this should be 2,250 pesos. What this means is that no, Luigi did not receive the correct amount. He was given 250 less pesos than he should have been. Now after we leave question 13, I do want you to pause the video and just think about it. If you had to guess, what would you say is the strongest animal in the animal kingdom? And I want you to just pause the video and just give it some thought now. Just give a guess. Alright, so a lot of common guesses are going to be things like the blue whale, or an elephant, or a rhinoceros. Now other people, when they see the word strongest, they might be thinking like a shark, or a tiger, or even human beings. Because some students will say, well, a human has a brain, which means we can build things to be stronger than any other animal. So there's going to be a wide variety of answers here for this question. Now, the answer is kind of a unique answer if you think about it in terms of what you can carry in relation to your body weight. Now, there's a fun fact out there that a dung beetle is actually not the world's strongest insect, but it is the world's strongest animal if you think about what it can carry compared to its body weight. A dung beetle can pull 1,141 times their own body weight. I want you to think about if you weigh 70 pounds. I'm just making this up. But if you right now, if you weigh 70 pounds, 70 times the 1,141 means that you could carry 7,987 pounds behind you. Now, if you're 100 pounds, if you weigh 100 pounds, that means that you can carry 11,410 pounds behind you. All right? It might even be more than that. I think it's actually 111,000. 114,100. So a dung beetle is actually really strong. Okay? So if somebody weighs 132 pounds, we want to see how much they could carry. Once again, a dung beetle, whatever it weighs, it can pull 1,141 times its own weight. So this is how much it weighs, and this is how much it can pull. For every pound it weighs, it can pull 1,141 pounds. We're going to use that to see if a human who weighs 132 pounds was as strong as a dung beetle, how much could they pull? So now we're just going to cross multiply and divide, or recognize the scale factor. In this situation, we're multiplying 132 times 1141. That's 150,612 pounds, y'all. Now, a lot of you probably weigh somewhere between 70 and 130 pounds. And I just want you to ask yourself if you think you can carry more than like even 100 pounds behind you, or 200 pounds. I mean, the dung beetle is clearly a very strong animal. All right, now that takes care of page 13. There's nothing on the back for page 14, which means we are done with these packets for now. Thank you.